Hi, my name is Sean Haler, and I am a data scientist at Elder Research. Today I'm going to walk through a solution to Advent of Code 2024 Day 1. In it, I'm going to highlight some basic Python programming functions, as well as the concept of an LP norm and a weighted sum. Those are things that all data scientists should know about. All right, the problem today gives us two lists, one going down on the left and one going down on the right. The goal is to pair up the items from this list. You want the smallest item first, so the 1 will be paired with the 3, then the next smallest item from each list, and so on until you've paired up all the items. I thought this would be a little difficult to do, so I decided to do a little hack and sort each list first. Then it's really easy to find the smallest item from each list. It's just the first element from each list. Then the next element from each list will be the next smallest, and so on down the line. Once you have the items paired up, the goal is to find the distance between those items. So take the difference and plug them into the absolute value function, and that'll give you your distance, in this case 2. The next item has a distance of 1, and then so on down the line. And finally, the problem asks you to sum up all the distances between each of the elements in the difference and get a total distance, which is 11. Now, this is a formula that I use to compute this. If you think of the sorted list on the left as the x vector and the sorted list on the right as the y vector, then that's exactly what I've done. And summing them up. And this is called the L1 norm. And the reason it's called the L1 norm is it relates back to this function. If we let p equal 1, then we get the thing that we had earlier. The concept of an LP norm is useful. If you think of it p as 2, in this case, you end up summing the squares of the differences and then taking the square root of that sum. And that should look familiar as the distance formula. If you let p get larger and larger and larger, maybe you let p go all the way to infinity, or you take the limit as p goes to infinity, you end up with what's called the L infinity norm, which, if you do the math, just turns out to be the max value that goes into the sum. Anyway, we're sticking with the L1 norm because that's what was used in this problem. Let's look at some code. I'm using Python 3.9.12. I'm also using the logging module. This first cell just sets up the logging module and defines a getString input function, which is something I use on all my Advent of Code just to read in the input into a file. Let's go ahead and run that cell. Here are the functions that I'm using in the solution. You can see I'm using split, append, and so on. These are all functions that any Python programmer should be familiar with, especially data scientists. You're going to use them quite frequently. All right, let's set testing to true and run through this. I'm not going to go through so much of this first part. Really, all I'm doing is reading in the input from the file into two lists called list 0 and list 1. When I run the cell, you can see that list 0 is the list I had on the other slide, and list 1 is the list I had on the other side. I'm going to sort them using the sorted function, and that gives me the two lists that are sorted. Those should look familiar from the slide as well. And finally, the solution is, in this case, is just a one-liner. I'm using list comprehension, looping through each index in the list. That's what the range function does here. It goes from 0 to length minus 1, which is the length of the list minus 1. And for each value I in that range, I'm going to pull the ith value from the first list and the ith value from the second list, take the difference, plug them into the absolute value function, and that should give me a list of differences, absolute differences. And then I take the sum, because that's what the problem wanted me to do. And I get a total distance of, in this case, 11. Now, if I run it on my actual input here, I get a solution of about 1.2 million. All right, let's look at part 2. We're starting with the same 2 lists, although in this part, we're going to compute a weighted sum of the first list. To compute a weighted sum, you just take the value for the first list and multiply it times the weight. And the weight in this case is going to be the number of times that value occurs in the second list. That's defined by the problem. So in this case, 3 multiplied by its weight, 3, and we get 9. Take the second value from the first list, multiply it times its weight. The number 4 occurs 1 time in the second list, so its weight is 1, and we get a value of 4, and you can continue on down the line. Finally, the problem asks us to sum up all of those values and get what it calls a similarity score, which is equal to 31 in this case. I've put here the formula for a weighted sum. You can see that we just have the value times some kind of weighting function of that value, and then we are summing them up. This should look very familiar it happens frequently in data science where you're taking weighted sums of anything. Also very familiar to statistics. All right, let's look at some code. Basically, everything down until this point is similar to the first one. In fact, it's almost exactly the same. I'm just reading in the input and getting a list. Let's go ahead and set that to true. And then we can run the code, and you can see that my similarity score does come out to 31. You can see this is my x sub I value. It's the ith element of list 0. And I'm plugging that into this function to get the weight, and the weighting function is the count function. So I take list 1 and I count how many times I see the x sub ith value from list 0, and that should give me that number there. Looping through all the indices and then summing it up, and I get the output, which is 31, which is what we had before. Running it on my actual input gives me a value of about 23 million, 24 million. Well, thanks so much for listening. As I said, my name is Sean Haler, and I'm a data scientist at Elder Research. My colleagues and I at Elder Research really love Advent of Code. We love solving problems like those found in Advent of Code. And believe it or not, we solve problems like this for our clients on almost a daily basis. If you are interested in joining us and helping us to serve our clients better, please check out the links in the description, or you can always go to our website at elderresearch.com. Thanks again for listening, and I hope you found it enlightening.